All right, party people, it's week 9, and we're going to look at a multi-part question. It has to do with finding area under the curve. Now, this is question 1 in the homework, and so you're going to want to use the area chart that I posted in the announcements for questions 1 through 4. Okay, so here's the question. Find the area under the standard normal distribution between z of negative 1.01 and z is 0.51. Use as many methods as you'd like, tables, calculator, Excel, round your answer to 4 decimal places. Remember that standard normal means that the mean is 0 and the standard deviation is 1. Okay, so what they're saying is, if we're looking at a standard curve, here's your mean of 0, and you have z-scores that are above 0 and below, right? So we know that our mean is right here in the center, but not all data falls in the dead center, right? Some fall above, some fall below. In this particular case, we're looking to see what is the area that is between negative 1.01, which is right there, and 0.51, which is right there. So these are your z-scores, or your deviations away from average. All right, so that's going to be 0.51, and we'll do a little dash vertical line, and negative 1.01, negative 1.01. Okay, so the goal is to get the area here in the center. Okay, so we're going to use some charts to help us out with this. So something that I copied and pasted from Alex is this little cheater sheet, I call it. It's a procedure table, and this may be helpful to you. So it says if you're looking up to the left of any z value, you just look up the z value in the table and use the area. If you're looking to the right, you're going to look up the z value and subtract from 1. The one that I'm interested in is between two values. You're going to look up both the z values and then subtract the corresponding areas. Okay, so this is the area chart that we'll use for question 1. And what I'm going to do is go find the z-score that corresponds with 1.01 and 0.51. So let's go discover that. So before we go and look at those charts, this is just a little snip of the chart. So this will show you that your z-scores are in this column. So let's say we wanted to find a z-score of negative 3.56. Okay, this would be our z. What would the area be? So you would come down to negative 3.5 and see how it's 0, 0, 0.1, 0.02, 0.03, 0.04, 0.05, 0.06, right? So we're looking at the 6 is in our hundredths place, so we're going to come down here and look to see where they meet. So it would be right there. The area would be 0.0002 for a z-score of negative 3.56. So that's how you read the chart. Okay, we want to find 0.51. So we come down on our z to 0.5 and come over to 0.01. So the area for 0.51 is 0.6950. Now this area, if you noticed, according to this picture, is from the left. Okay, so 0.6950, let's go ahead and shade that in up here. That is the area from this tailpiece up to this piece here. So that's 0.51. So 0.6950. So that's roughly almost 70%. Now we want to find the area in here. So let's go find 1.01. So I'm going to come down to the snip for 1.01. All right, and it's negative. So negative 1, remember this is 0, 0, 0, 0.01. So if we come together, we come to 0.1562. This is negative 1.01. So that area is 0.1562. So what is that? That is from here to here, 0.1562. Okay, so if we want to know what's going on in here, all right, in the centerpiece here. Let's highlight that. If we want this, we need to subtract. We need to take the bigger piece, 0.6950, subtract out the little piece, which is this piece right here, and that'll leave us that little chunk there. So 0.6950 minus 0.1562. So if we do the math on that, we should end up with 0.761. I'm sorry, we should not end up with 0.761. Let me break out my calculator here. Okay, so 0.6950 minus 0.1562 leaves us 0.5388. Okay, so that's what they're looking for when they're asking us to find the area between these two z-scores. And roughly, if you think about it, let's go back up here. Right, does it make sense that from here to here from here to here is 50%, right? So, and then if you go a little further, that'd be closer to 60%. So if we're just looking for this piece in here, that's a big chunk of that. That's 0.5388. Okay, I think that's it for that particular problem. All right, we'll see you in the next one. Bye.